All right, so basically when we start getting into the stuff, there's a bunch of considerations. We have to start considering network, storage, power, scalability, expertise, because we're talking about on-prem. And some of the stuff we take for granted in AWS, like who's thinking about power when we're talking about Amazon? You're not, because they don't bill you on that at all. Like it's one of the few things that they don't bill you on for usage, so you actually have no concept. Hardware wear and tear, no concept. You max the CPU 100% on that box day in, day out, no concern, not your problem. That's Amazon, right? But if it's your gear, you're like, it's probably going to wear out that box sooner, so we're going to have to buy more of those boxes, so maybe we don't want to do that. So, and this is just the tip of the iceberg when we're talking about this stuff. So some of the stuff that I work on, where I work, the ingestion kind of looks like this, give or take. So EPS is events per second, and the average message that we take is about 512 bytes, and you start looking and you're like, okay, so it's 409 megabits per second. And the other thing is, so this is what we currently quote unquote do, let's say, and this is what we're projected to do in, let's say, like the next year, quote unquote. And you start realizing like, oh damn, we actually start getting into serious problems on-prem. Because everyone, when on-prem was considered at some discussions and whatnot, people made it seem like we just go buy some servers and some racks and like that was it. Like we're done. Just put some hard drives, some servers and network switch, that's it. And when you start thinking about it, it's like, it's not quite that easy because there's a bunch of things that like the cloud just does for you. Like you're not sitting there mostly concerned about like the global switches at AWS. Are we going to max out capacity? Or like, you know, my commit with my provider is going to a switch that only does 10 gigabits a second, but now we know that we're actually going to be at 25 gigabits a second for like recovery because we're dealing, this was also about streams as well, unrelated, but well, I mean, related to last talk, but it just so happened to be about streams at where I work. So people just take a lot of this stuff for granted. When we got to storage and you start running this through, you kind of get in the same scenario, which is like, okay, so we look at 100K, let's say this is what we're doing now and protect it. And you start going, bro, you want me to buy 5,600 hard drives? Like this is not even something like, look, annual failure rate is 500 drives. If you start looking at the percentage of drive failures, this is not something that you're just like on a like Wednesday day, you're like, oh, there was 50 drives that failed. Let me just go buy 50 drives. Like you're at spots where probably companies aren't even going to have 50 of these 8 terabyte drives. It's not just a one click, oh, that will be here in 3 hours because we are in the middle of a crisis mode, right? But Amazon just solves this for you. I feel like this is becoming an Amazon commercial at this point. Not Amazon, you can sponsor us. No, I'm just kidding. But a lot of people just like, could you imagine having like day one, let's say we want to do this. You show up and you're like you're like Tiger Direct or something. You're like, yeah, I need 4,000 hard drives. I need 8 terabyte drives. And they're like, what? Like, you can't even do that. Like, so where do you even buy this kind of stuff? And this is only 20 PB, and internally we discussed that this number would probably even be much higher and stuff like this. Like this is the ultra conservative number. We were projecting like 10 times this for other stuff. And you're like, oh my God. So that would be like, you know, 51,000 hard drives. You're like, wow, I really, really like Amazon right now. Like I like when I can open up the UI and I'm just like spin up 600 of those EC2 instances. And that poor data center guy who had to rack all that stuff. So we just bulk buy, right? No problem, because people are just like, no, I know someone. We can get the drives. Don't worry about that. So same vendor, same manufacturer, same batch, and good luck. Because this has already happened twice where certain drives have bricked themselves. So now you can't just buy the same drives. You can't just bulk buy. You want to distribute different drives for different brands, because what we've seen is, like in this case, after 5,184 hours, these drives just stop working. And if you happen to buy 5,000 or 50,000 of these same drives because you're like volume discount pricing, right? Like I want that 40% off my drives. And then literally your DR and everything dies at the exact same time across your entire cluster, basically probably within a couple hours a day. Like you're just bankrupt. You're done. Everything you had is just gone. And normally have a nice transition, but that didn't come. It's like they've learned their lesson. Actually, this just happened. This was like 4 months ago, I guess now. So 4 months ago, they had the exact same issue where these drives after 32,000 hours just died. They're unrecoverable. All the data is just GG. So it's like, at least with Amazon, there's such a high volume of purchase and over so many different drives of different ages of different purchase that this is not even something considering. You're like, Cory, this is sounding conspiracy-like likelihood is unlikely that we get the one drive that happens to be like this. But it's also like, these are all things that you have to consider when you're thinking about on-prem, because we normally don't have to. So you get into things like, fuck, I remember going and getting a server and like a ruler and actually like checking, being like, okay, if this SATA storage connector is this wide and we have these many ports, how many can we optimally fit here? And if with one U and this, and okay, how many racks and what's the power? And like you start having to really consider out capacity, like physical planning. Like when I say capacity planning, I don't mean like just like in terms of hard drives. I mean like physically, like, okay, how many spare racks do we have in case one of the racks themselves break? It's like, and where's that stored? Because in tiny scale, you're just like, we store at the bottom of the rack, a couple of drives at the bottom or something. But when you're talking about something like, what was that? It's like 500 drives. It's like, where are you storing 500 drives in the data center? Either you just have some like leased space that's in a corner with 500 drives just stacked up and you're like, yep, that's our drives. Make a little chair just for the ops person who has to sit in it. Like, so now when you do the research and you really start looking into this, you realize, okay, there's this company BACKBLAZE. They do amazing blog. Every year or almost every pod release or storage pod release they list out all the specs. And I mean all the specs. Like they give you the actual diagram to bring it and actually get the chassis like manufactured, exactly like the wiring for every single thing that goes in there, like how to make this, every single, even the screws. They have the count of screws that go into this and the price they pay per screw and stuff. Like they're really detailed. So you're like, okay, great. So I don't have to solve all this stuff. Someone's already done it. We'll just buy a ton of these and we'll just start doing it. And you start considering things like, we're in a meeting or like, guys, this is easy. We'll do this. And I'm sitting there, I'm like, okay, how much ampage do we have per rack or per line that gets ran? And people are like, what do you mean? And I'm like, well, this is going to, if all the drives spin up, it's going to draw 24 amps. And most data centers, what people don't realize is usually like 15 amps for each rack that you're getting, and you can get them more, but you usually pay more for this and things like this. And no one had the answer in the meeting at that point. And immediately you're like, yeah, this is a bad idea because no one could give me the answer, which means like there's tons of unknowns here. Like if you're sitting in a meeting, you're like, how much power draw can get per rack? Because we have a small little data center that we have some stuff in, and it's like, I think it's 25 amps. It's like, really, we're gonna be that close? Like, oh my God, it's like, so we can basically just do one pod per rack. We can't even utilize the full rack. So we're just gonna have a data center of like racks with only one of these 4U boxes in them. We're like, nah, we can run another 25 amp line in, but we have to pay like $2,000 a month for that. And it's like, okay, what's the cost per square foot? You start figuring out, and in our scenario, I think it was cheaper for us to not pay for the additional line and just have like these racks with 4U chassis in them and just tons of them. And we're like, okay, that pricing seems off to me. They're also very heavy. Like you get into things like, okay, let's say we can run indefinite power to the rack. Yeah, if it's a raised floor, the floor itself is going to collapse after 1,100 kilograms. Actually, I think, wait, it's the rubber on the rack will crush at 1,100 kilograms. The floor itself is rated for 2,000 kilograms. So if you exceed that, you could literally kill someone. There's a 2,000 kilogram rack that is going to fall, preferably not on your employee who would be crushed and die. Also, what data center wants to work with you if they show up one day and they're like, bro, why is there a hole in the ground? Like, what happened here? Like, we've never had this happen. Well, yeah, we found these storage pods, and we just tried to fill them with 60 hard drives, and we tried to stack up, 10 of those in a 40U or 44 some, what is it, 44, 42U? Like 40-ish U rack, and the floor collapsed. And God forbid, because there's going to be interconnect and crossover into your rack, and that's going to be connected to stuff. So you have this rack that's going to, let's say it just falls straight down and doesn't kill anyone. It's connected to other things. And all of a sudden that stuff's coming with you. And who knows what you're pulling with you, because as a data center, there's very little slack. Everything's measured out. So they don't expect all of a sudden the rack on your server to be here and drop like, 8 feet. So yeah, there's a lot of problems here. People started to get a little hesitant when I was like, I showed them this, and this was a legitimate quote I found online from Facebook engineers where they actually ran into this problem when they were building out their data centers, where it was like, yeah, we found out that no one had actually thought about these rubber wheels just like totally getting destroyed. And we had to go back to the drawing board and refigure this out. I think the short answer was just like, we remove the wheels and we just mount them directly to the floor, which is like this ultra hack is like, okay, we don't need the wheels, just mount to the cement and problem solved. But AWS, you don't think about this. This isn't your problem. Okay, so you get into tons of things like, how do we even lift this thing? Like, will the rack, the rails itself support it? What about vibration, right? Like, could you imagine a rack with like 10 of these and you have 60 drives in each of them? So it's like 600 drives in each rack. Is it going to have such a vibration that the rack itself starts shaking, right? Like, so thankfully, Backblaze discusses that they have dampeners in here, so you don't have to worry about disk loss. But V1 pods didn't have dampeners, and they did have disk loss from the sheer vibration of all these drives spinning. So let's talk about how do we lift this. I didn't even know you could buy these things. You can, like, you have to have 2 people lifting these, or you have to buy literally like, what, I don't even know if I put the name. I think they're just called literally server lifts. Like, so great, in your data center, you gotta have one of these now. So there's tons of other issues when we get into this, like bit rot. Like, bits are just gonna flip on the drives, whether or not they're doing anything eventually, right? Like, given enough drives, you will have a random bit flip. So how do you confirm that the bit has flipped, and how to restore from where? From your backup. So there's tooling for this. Facebook has this issue. They wrote stuff for this because at their scale, it's like you have, millions and millions upon drives and tapes too, and you need to make sure that literally like there's not a random bit that just said flip. Signal, it's like, okay, so given I have that many racks and, Cat 6 goes this far, have I exceeded the Cat 6 limitations? Am I going to have signal degradation and things like this? What do I do about compression? How am I compressing? Basically, we were looking at doing HDFS. So it's like, in our company had run HDFS at this kind of scale. So it's like, do we really want to go down the path of running this massive, like, let's say 20 PV HDFS cluster and no one has experience with HDFS? Like, we're just asking for some scenario where it's like, whoops, I didn't know that would propagate across the whole cluster and wipe out all the data. Like, whoops. How do we optimize this? Hotspots on each of the drives so that, like, how do we detect this? How do we observe this? How do we find them? How do we fix it? How do we move data off? Do we write the tooling? Is there tooling? Monitoring on-call duties. So it's like someone's going to have to wake up, or we're going to have to pay ops, like remote hands for this, but someone's going to still have to communicate with remote hands that, like, hey, there's an issue, I need drive blah, replaced with our giant hard drive chair in the corner, take one of those boxes. Like, so you're just like, Cory, of course, Amazon, bro, no one does on-prem anymore, just Amazon. Yeah, except at this scale, we start getting into problems like Amazon's really expensive. Like if I want to go there and store like 20 petabytes and search it, because the data that we do is analysis, so it's not just we store it and forget it. Like, you know, that's pretty easy scenario. How do we reduce network costs? How do we reduce general cost? So internally, everyone's like, Glacier, Glacier, Glacier. It's just Glacier. And then when you look at Glacier, you realize, wow, Glacier is great when you never have to touch it. But if you have to touch 2 petabytes of data just once, it costs us $40,000. And the tool that we use is ad hoc analysis that faces the customer. So a customer can come in any point of the day and literally just be like, I want data from point A to point B. And if the customer has 2 PB of data, we just paid $40,000. And God forbid they hit refresh 5 times. Like, like it's just like this model is not going to work. So Glacier is clearly not going to work for us. So the S3 land of data transfer, and you realize, like, dear God, Amazon, your pricing is complicated. Like, when you think you know the pricing, it's all a lie, because you get into things like, okay, S3, there's going to be costs for like, oh, the request, oh, different requests, oh, there's different pricing for get and selects. Oh, there's not a lifecycle transition request for this, but there is for other ones. There's data retrieval request per 1,000, but not for all of them. And there's data retrieval. What the, aren't these fucking kind of the same things like WTF? Okay, but 0 is great. So we really like 0, because S3 Glacier was 3 cents, 1 cent, 25 cents, or so it's fractions of cents, right? So yeah, we like 0. 0 is good. So this is why we can't use Glacier, as well as like people like infrequent access and things like this. But the moment you get to anything above 0 for like 2 PB, it's just like, it's too expensive. Like well, it wouldn't be so bad if we were like internal only data. We only do this and that, or we only have the data for like lawsuits or something like this, or no one touches the data, or okay, once a year we have to do it, or 4 times a year we have to do it for like quarterly reporting or something, no problem. But when you have it customer facing, you're like, yeah, no, 0, like 0. So there's obviously a catch, it's Amazon. So you have to stay within your own region, because don't you love that this page talks about S3, right? And then, sorry, you actually see right here, data retrieval 0 cents. Great, 0 cents. No, lie. 0 cents only within your same region. If you leave your region, you pay the 2 cents per gigabyte network cost out of your region. So then if we wanted DR somewhere else outside of our region, we would pay 2 cents per gigabyte. And when you start looking at like petabytes and petabytes of data, you start questioning, do I need that DR? How much do I need a DR? Can I just get away with multi-AZ DR? Like whatever, like you just look at the business case. But yeah, so you find out crazy things like Amazon's AZs are a lie. Like they're not actually what they really are. So yeah, US West 1A and my account versus John's are actually entirely differently potentially, because on the UI for the AZs, the UI isn't always reflective of what it actually is. The reason why, when you sit down, there's actually a doc page that talks about this and why AZ IDs are really important. It's only for the availability zone, not for the region. So if you're in US West 1, you're fine. US West 1, or sorry, US, what is it? US West 1, it's the same, but not the AZ. So the B, A, B, and C will change, yeah, for the availability zone. And the reason why they do this is so that not everyone's on the default, is the very long story, because then they would have one disproportional availability zone. Because if you were, say, the default UI was US West 1A, everyone would probably be deploying on US West 1A. And then you would have one availability zone that would have to have way larger capacity than anyone else. So they basically do a UI hack, which is they just show you something else. But you can get this from the API and actually find out really where you are. And this is important if you have things like, other services that do get billed leaving their availability zone. And you want to make sure that your cluster is talking in the same availability zone as the other services. But let's say you have different accounts for different teams and things like this. All of a sudden, different accounts means that you might not be in the same availability zone, especially when you do like pod management and things like this. And let's say you have Elastic Kubernetes service and it's on different teams and different accounts, but you want them to have, I don't know, be able to connect to each other in the same availability zone only if they're in the same availability zone. You gotta need to know this. So how do we efficiently store it? S3 is fine. How do we reduce network costs for some of the services? Just stay in your same AZ ID. How do we reduce general costs at Amazon? Spot instances. So not everyone will know about the savings plan, even though it's kind of new-ish, old, I guess, sort of, depends on how you look at it. It's like 3 months old. The savings plan, if you are on Amazon, look at it. Is the best thing ever. So they have something called reserve instances, which a lot of you will probably be familiar with reserve instances. You lock yourself into that instance type, and that's it. So if you have an i3 and you do a reserve instance, you're stuck on i3, that's it. Which is crappy because now, in our case, let's say we're on Elasticsearch and it's like, well, I can buy i3s, but maybe I plan to remove Elasticsearch. So now I'm stuck with all these instances are SSDs and I might be moving more to a memory kind of architecture. So the cost savings plan or savings plan is very nice because you basically just go and say, I am upfront paying for X compute per hour. That's it. And they come back and they calculate out, given what you're going to be spending on what instances across your bill, I would say it's $100,000 a month. And they will, for EC2, they will come back and say, okay, if you pay me like, I don't remember what it was. I think it's like the whole bill up front, they'll give you like a 40% discount for the first year. Or you can do 3 years up front and you get like a 60% discount, which actually adds up a lot. And you can move instance types. You can switch to family, you can increase, you can move. It's over the total compute per hour. That's it. So it's like the same thing that you get when you buy any service normally as a person. You go to buy your internet and they're like, yo, we're charging you $20 a month. But if you pay for a yearly upfront, we're just going to discount you like, 20, 30, 40, 50%. So this is not on all services. One of the downsides right now, unless it's changed in like the last month, is if none of the managed services count. So that's really crappy because if you're using the managed services, you don't get this free 30 to 60%. But if you are using just raw EC2 and you're managing it yourself, then yeah, you pay, there's even a discount for no upfront. So you can do 1 year commit, you commit to spend like $60,000 a month and they'll give you like 20% off and you don't actually have to upfront the bill. But for companies who do have the cash, you can get a ton of savings up to 60% just by paying 3 years upfront and committing that you'll be at Amazon for 3 years at X spend per year. So, and obviously scaling groups, we turn things down and when we're not using it and spin things up when we are. I think this is my end slide. Yep. So yeah, that was my backup presentation. Questions or no questions? We have both because we're a DNS company and we sell the physical server as well with it. So we have to have some on-prem to do actual testing, like because we're actually selling real hardware. So Amazon is nice for a bunch of like the random, like we need to run unit tests and dev stuff or POCs, great. But at the end of the day, it's like, no, like we actually sold a real physical appliance. We have to at some level of test on that real appliance. And then the other place I used to work at before was like 90% cloud, 90% on-prem and 10% not. And we were just talking about why, which is there's one major thing with Amazon that you should never be on it for is if you have large network out, you should not be on Amazon. Like, because it's 2 cents per gigabyte out. And it's been the same pricing for 8 years. And that's really expensive. Like, that's actually really expensive. Like, it's not so bad if you just have like a small thing, or you're, you know, like a blog or whatever, or you don't have a lot of like, once you go to like multimedia, oh God, it's crazy. Like, you can run the, like, you know, let's say the 25th largest bandwidth consumer in the world for $600,000 a month. If you just buy the commit outside, get it unmetered, you can do fancy things like 95th tile billing, which means that they're going to drop the 5% lowest, 5% highest of your bill, and then they're going to charge you on whatever the average is, right? But what you can do is you can have it so that, let's say it's a video, someone clicks play, you spike the traffic, and then you throttle it. And because it's video, they're only going to watch it in real time of 1 second of video. So you cap it at X. And what's going to happen is that spike, that when they drop the top 5%, is going to drop most of your bill. Yep. No. Yep. Yep. Not really, because in the grand scheme of things, like, the most valuable thing in our company is development time. So it's true to most companies, because if you're like, oh, we have a performance issue, it's terrible to say as devs, but we can just throw money at hardware and mostly just pay that way. But I have a finite amount of people, right? And you could say, well, we can get more people. And it's like, and you go talk to your recruiters and your company, and they're like, God damn it, we're struggling for people. It's like, so there's a finite of development capacity. And a lot of companies usually have way more money than development capacity. So it's like, I'm willing to pay and just absorb that. Actual optimizations for like the cloud itself, no. We know that we'll have noisy neighbors, obviously, versus the dedicated hardware. Amazon does allow you to select solo instances where it's just you. And even then, if you want to go to like the extreme, it's like, you can look at Outpost, which is basically Amazon ships their own rack with their own, you configure it, what types of instances you want, and they ship it right to your own data center, and you run Amazon in your own data center. You'd only do this if it was like latency sensitive stuff like trading, or you had contractual obligation where it's like, no, I signed agreement with X company that says that all data for them will be on hardware that resides in my data center. Great, you can hack the model. Amazon ships you the rack. It's in your data center. The control plane is in Amazon, but all the data is going to reside there in your data center in that rack that just happens to be ran the Amazon way. So now we haven't moved anything to like serverless or anything like that. Like, so yeah. No, I mean, we already had stuff there, and the other stuff is like the managed services are just so many. And then, you know, there would have to be a compelling thing. Like, there's already so much open source support for a lot of like S3. Like one of the things that we're using is Presto. And with the Hive connector, or what they call the Hive connector, you can use S3. So I'd have to then look, is there any support for Azure's equivalent? Has the community did that? No, how much work would it be for us to do it? Is it compatible? Is it not compatible? Versus the community has already put so much effort and support into that world that we'd have to like a really compelling reason. And I'm pretty sure, like, you know, not even knock on wood, if Azure was like 20% less, I'm sure if I show up at my AWS account rep and it's like, you got to cut our bill 20%, they'll just do it, right? Like it's competitive market. I have nothing against Microsoft. It's just one of the things is we do have Presto and it does work with S3, and I have no idea if it would work with that. So, yeah. Okay.